When a greenhouse of tomato plants turns brown and wilts before harvest, the cause is often a bacterial disease like spot or canker. Once established, these diseases are incredibly difficult to stop. The source of this devastation often hides in plain sight. This is a microscopic photograph of a tomato seed. It is covered in fine, hair-like epidermal cells and surrounded by a sticky pectin gel. Bacterial pathogens attach directly to these hairs and hide inside the gel, waiting for next spring. Before attempting to save your own seed, there is one absolute rule. You must start with open-pollinated or heirloom varieties. F1 hybrids are a cross of two different parent plants, and their seeds grow into unpredictable combinations of traits that rarely match the fruit you ate. If you want to preserve specific heirloom genetics, extracting the seeds from the fruit and chemically sanitizing them is the only way to do it without guaranteeing a diseased crop next year. Step 1 is extraction. Slice a ripe tomato and scoop the seeds, along with the fluid surrounding them, into a glass jar. The immediate biological obstacle is that pectinaceous gel sac surrounding each seed. In nature, this gel prevents the seed from germinating inside the warm, wet fruit. But for us, it actively inhibits germination and acts as an armor shield for harmful bacteria. To break down this barrier, we mimic natural rotting. Leave the jar in a warm room between 72 and 86 degrees Fahrenheit for 48 to 72 hours. During this controlled fermentation, you will likely see a layer of white mold form on the surface. You must monitor this closely. If you leave the seeds in the liquid past 72 hours, the gel breaks down completely, and the seeds will sprout inside the jar. Once they sprout, the entire batch is irreversibly ruined. By utilizing this brief 3-day window of controlled decay, we transform the seed's protective gel from a pathogen-harboring armor into a harmless byproduct that we can easily wash away. With fermentation complete, flood the jar with cool, clean water. This begins the density sorting process. This animated diagram shows exactly what happens inside the jar. Dead seeds, pulp, and mold are buoyant and float to the surface. The dense, viable seeds we want to keep will sink to the bottom. Pour the floating waste down the drain. Then dump the remaining water and the heavy seeds into a fine wire mesh strainer and rinse them thoroughly. Next is the chemical strike. Mix a solution of 1 part standard household bleach, specifically 5.25% sodium hypochlorite, and 4 parts water. Add a single drop of dish soap to break the surface tension. Drop seeds into the solution and agitate them constantly. You must restrict this bath to exactly 60 seconds. Immediately remove the seeds and rinse under cool running water for 5 uninterrupted minutes. This flushes away all chemical residue. This precise timed exposure completely eliminates the bacterial threats resting on the surface of the seed coat, doing so without penetrating deep enough to damage the delicate embryo inside. With the seeds fully sanitized, tap the strainer against the sink to shake off any excess moisture and prepare for the final drying phase. Spread the seeds out in a single layer. You must use a smooth surface like a glass plate or a flattened coffee filter. As this graphic shows, you should never dry seeds on a paper towel. As the seeds dry, they will act like glue and fuse permanently into the fibrous matrix of the paper. Leave the seeds on their plate or filter in a dry, air-conditioned room for about 2 weeks. When they are completely dry, use your fingers to break apart any seeds that are stuck together and drop them into a breathable paper envelope. On the front of the envelope, write the exact tomato variety and the date. You also need to write the word treated in large letters so you know this batch went through the chemical strike. Place the paper envelope inside an airtight glass jar, seal the lid tightly, and store the jar in your refrigerator. Achieving total desiccation and utilizing cold storage locks the seed into a state of suspended animation. This preserves its viability and its genetic purity for years. You have successfully engineered a personal vault of pristine, disease-free tomato genetics ready for next year's planting. If you keep these seeds in storage for multiple years, you should run a germination rate test to check their viability before committing them to soil. To test them, roll exactly 25 seeds in a damp paper towel and place it inside a vented plastic bag. Keep it at roughly 75 degrees for 2 weeks. Count how many seeds sprouted, divide that number by 25, and you have your exact germination percentage. Mastering this precise extraction and sanitization protocol is your ultimate defense against cyclical garden diseases. It empowers you to permanently secure your food supply and enjoy your favorite harvests year after year. Thanks for watching, and remember to subscribe for more advanced gardening guides.